Hey Unity Audio folks! Today we're going to be setting up some beat detection and some custom event marker detection in FMOD using Unity. This is super useful if you want to build any sort of rhythm game, although it's a little more complicated if you want to do a game that has like kind of a preemptive detection of where the beat and custom rhythm events are, but you can use this as a starting point for that. It's really cool if you want to do like tempo tracking and things of that nature for games similar to like Crypt the Necrodancer. So I'm going to be going back to the twin stick shooter we worked on in the last video, the parameters video, and this time adding some super simple arpeggiated music to it, doing some beat detection off of that, and spawning enemies on the beats, as well as syncing the player's shots to the beats. So hopping over into FMOD, we have now hooked up this music scene. As I just mentioned, it just plays an arpeggiating loop. Here's kind of what that sounds like. So nothing fancy at all, it's just kind of one simple layer, but it should be plenty to showcase what we're about to do. So if you right click, you can add a tempo marker using add tempo, and anywhere that you drag this will be the start of the tempo that you are assigning to the track. So for instance, if I wanted it to be at 160 BPM and 3/4 here, you can see that the timeline changes to adjust accordingly. But for this track, just to show it off, we are working in 120 beats per minute at 4/4. The system I'm about to set up should work in pretty much any time signature. The other thing I'll be going over is showing how to read in these custom destination marker events, and you can do all sorts of weird things with these. I have a separate write-up which I'll link in the description below on how I use these to make essentially a beat detection system. It's something I've played around with twice now, and it is a lot of manual work to set it up the way that I'll be showcasing in that, but it does function. All right, so jumping over into our Unity scene, you'll see we've pretty much are picking up exactly where we left off, except I have gone ahead and added this music manager script in with our custom music event. So now when we play the game, the music is playing on top of what we previously had. So to start off, I'll open this up. And as you can see, there's nothing too complicated going on here. As opposed to last time, we were tracking all of our music instances within the code and keeping them pretty contained. This time we are increasing the scope of this music instance to within the class as opposed to within part of a function. And to accommodate for this, we are making sure to release it on destroy, which means when the object itself is destroyed. So when FMOD is doing beat detection, it piggybacks off of a system that it has known as event callbacks, and I'll leave some links to the FMOD documentation about event callbacks in the description as well. But the short of it is, we're translating the C# code we're writing really closely into C++ code. And so for that, we're going to need some kind of low-level systems libraries. So first off, we will need system, but additionally, we will need the runtime interoperational systems or services library. This is used for managing low-level code within C#. And the reason we need low-level code is because we basically want to be doing like live streaming in data, and we want to be able to ignore garbage collection for that so that we don't lose the pointer or the reference to the pointer that's going through our event data and searching for like tempo changes and beat detection, things of that nature. So the first thing we are going to also want to do is turn our music manager into a static class so that we can do what we did last time as well and access it easily outside of the music manager without having to manually pass references around a bunch. Next, we're going to want to write a custom class for our timeline info, and this will hold things like our current beat, our most recent marker that we hit. You can also have it hold like the length of the song and the current position in the song, things of that nature. Anything that we're going to need that can be pulled from FMOD event callback data. So for that, the first thing we're going to do is we're going to make a class that has a structs layout, and the layout memory is going to be sequential. And C# does have a tag for this. It is this layoutKind.sequential tag. And our struct itself, or I guess our class itself, we will call timeline info. And we will place our variables within this class that we'll want to access and store our event callback information in. And for that, we want an FMOD string wrapper for the last marker. It's just an FMOD unique string type, and an integer for the current beat that we're on. Now we want a variable to store our timeline info in, and we want that to be public so we can access it through our instance. And the other thing that we're going to want is what's known as a GC handle, and it's a variable from which you can use to access managed memory during runtime. And we will call that our timeline handle. Additionally, we will need an event callback variable, which we will call our beat callback. And that'll be all for now. There'll be a few additional things I'll be adding once we've set up the kind of initial beat detection. But yeah, for the moment, that's all we're going to need for our variables. The next thing we're going to want to do is create a start function separate from our awake function. Start executes later than awake. And in the start function, we want to check to make sure that we have our music assigned. And then if we do, we're going to instantiate all of our timeline info, kind of logic for setting up the connections between the music events and the memory that we're going to need to be accessing. So first, create an instance of our timeline info on start. That's this up here. And then we'll do the same with our beat callback, this right here. And this is where things get a little weird. So we want to pass in a type for the beat event callback, and we are going to actually define this outside of this variable. So I'll start by commenting this out. Then going down to the bottom here. Again, this is all outlined in the documentation that I'll be linking below. But basically this is going to be of the type of FMOD result, and that needs to be called back from unmanaged memory. So to indicate that, we need to give it this tag of type monop invoke callback, and then give that the type of FMOD Studio event callback. And we're going to want to make this a static type with a return type of FMOD result. And now this function that will return the result type, we'll call it beat event callback. And it takes three things. It takes an event callback type, takes a pointer to our event instance, and a pointer to the kind of parameter data from our event as well. Now within this function, we're going to need to first grab our event instance through the event instance pointer. And then we're going to need to save the pointer to our user data, as well as the sort of result from this instance. So this result here is basically just used to determine whether or not we got the result we were looking for, so we can throw an error if we didn't. Whereas this int pointer here is basically what we're going to be using to pull all of the data that we're going to need from the event. So to do that, first we'll set up our checks. Then we're going to get the object that we're going to store the beat and marker details into. And then depending on the type of the information that we receive, be it beat detection information or marker information, we're going to create a switch statement to kind of designate what to do with that information. And assuming we make it through all of this, we want to return our OK result. This just means that we didn't run into an error and what we're passing in is in fact valid timeline information. Now within timeline beat and timeline marker, we're going to create a variable for our parameter, which is going to essentially look at and hold the types of callback information that we're receiving. So in beat, we are going to be looking at essentially timeline beat events, and in marker, we're going to be looking at timeline marker events, or in this case, they're called properties. And now in here, we can save the information that we're reading in from memory to the timeline info variable that we set above. So for the markers, all we want to save is the parameter name, which is the name of the marker essentially that we've run into. Whereas for timeline beat, we could save a few things. For this project, we're only going to save the current beat, but we could also do parameter.bar, parameter.tempo. I'll pull it up in a minute and show exactly the different types of things you could save. So as you can see, we have bar, we have beat, we have position, which is in milliseconds, I believe. It might be in samples, but it's an int. We have the tempo, the upper and lower time signatures. But as I mentioned, we just care about the beat for now. As a note, timeline marker can also pull the position of the marker that it's reading. Cool. So now with our beat event callback type/function return finished, we can go back to here, back to our start menu, and throw our beat event callback function, or type, I guess, into this event callback function. Now we need to set up our timeline handle and kind of pin it, which means that it will ignore garbage collection. And then we need to take that timeline handle, which is essentially our tool for accessing our callbacks, and assign that to our music instance, as well as set up our callbacks on our music instance so that it'll be searching for beats and markers. And the final thing we need to do, because we're kind of managing memory in a way that's not super conventional for C#, is we need to free our memory management on destroy, or whenever we would kind of not care about it anymore. So for that, on destroy, we're going to set our user data pointer back to 0. And we're going to free our timeline handle. Cool. And that's pretty much everything we need to get our beat events working. And if you want to test that it's working properly, we can use Unity's kind of debugging on GUI tool. Basically what we're doing is we're creating a GUI box, and we are reading our timeline info for our current beat and our most recent marker in that GUI box. So we'll save this, and then we'll test to make sure it's working. And as you can see, our beats are updating. Now we've hit our first marker. So yeah, that's pretty much it for setting up beat detection in its most simple fashion. I'm next going to go through and set up the examples I talked about earlier of making the enemy and power-up spawns spawn on the beat, and then I'm going to do the same thing for the player shots, just to kind of give some more concrete examples about how this can be used. So in order to set this up, I'm going to use Unity's delegation, event delegation system. Basically how this works is you can subscribe a function to an event, and then whenever that event happens, you can basically call that function by proxy. So instead of checking for something on update every single time, or every single frame, checking for like an if statement or something, you just kind of have it trigger whenever it shows up. Don't believe it's any more efficient. I think under the hood, it's still kind of doing that same if checking per frame. So it's not the most efficient way of doing things, but it's really, really nice for code organization. So the first thing we're going to need is a reference to our most recent beat and our most recent marker. And I'm making these both static again, just like I was making this class static at the top here, because we're only ever going to want one of these, and we're going to want to be able to call it from anywhere in our code. And now I'm going to set up the event delegates, and we're going to want both one for beat events and one for markers. So what we'll actually be calling is this marker updated and beat updated function. And we'll be calling that within this script here whenever a marker has been updated or a beat has been updated. But then in other scripts, we will be able to subscribe to those updates and kind of piggyback off of them. So the next thing I'm going to do is create an update function that'll track that logic. and that's all there is to it. Both for the marker string and the beat, we are checking to see every update that what is in these static variables up here is different from what's in our timeline info. And if it is, we update the static variables and then call our marker update or our beat update. Now, the next thing we're going to do is actually set up how you would piggyback off of these. So we'll start with the enemy spawning and the power-up spawning. So for that, we're going to want to hop over to our periodic spawner here. It's on both our enemy spawner right here, as well as our power-up spawner. And I'm going to set this up so that the enemies start spawning from the very start, but the power-ups don't start spawning until we reach that first marker, this music body one right here. So we have this whole 4 beats, or I guess 4 bars at the start, 16 beats, that will go by before it'll start actually spawning power-ups. So for that, I'm going to make a Boolean to basically check to see if we should do that operation. As well as a string field so that we can designate which string we want to wait for specifically. And in this case, I'm going to go ahead and assign it here. Generally, it'd probably assign a blank string here, so it for sure wouldn't do anything. But because we're just creating a tiny prototype, I'm going to go ahead and do this instead. And our spawn interval is going to be based on beats rather than on seconds. So I'm going to make that an int instead of a float. And just to make sure it starts as soon as possible, I'm going to move all our start code to awake. We'll also make next spawn integer for the same reason. And on awake, we're going to set our next spawn to our spawn interval. That way there won't be a spawn immediately. It'll wait for the next interval to tick. We could opt out of doing this if we wanted. I think it makes a better result, both from a gameplay perspective, and it's slightly more rhythmically interesting. But you could play with this sort of thing. You could assign a different value here or whatever. It's totally flexible. I guess we already had that. So we'll clear this. So we're no longer going to need this update function because we're not going to be spawning anything on update or checking any time intervals on update. Instead, we're going to do that all through the subscription to the update loop in our music manager, this here. So instead, we're going to put all of our time logic in spawn, or I guess our beats logic. We're going to first see if we're waiting for a string, and if we're not, we'll continue, and we'll see if our next spawn has come up yet, or if it's not come up specifically. So we'll be spawning when next spawn reaches 0. So when we're essentially treating it like a timer ticking down. So it'll go, if we're waiting 2 beats, it'll start at 2, it'll go to 1, then it'll go to 0, and then the next time it reaches, it'll recognize that it's at 0, and it'll trigger. But if it's not at 0 yet, we'll decrement, and if it is, we will run our code that we previously had to spawn, and instead we will set our next spawn equal to our spawn interval -1, because so if our spawn interval is 2, and we set it to 2, then it would tick down to 1, then it would tick down to 0, and then it would run. And instead we want it to immediately kind of tick down to 1, because we want to count the beat that we're on. The other function that we want is the one that kind of pays attention to whether or not we're waiting for a marker. And all this is going to do is check to see if we found our marker yet. And if we have, we will indicate that we're no longer waiting for a marker. And what that'll do is it'll mean that we skip all of this code until this is passed. So to make these run, we need to, as I mentioned a few times already, subscribe them to their respective functions in the music manager, the beat update and marker update. And we can do that on awake. And all that looks like is this. Now, whenever a beat is updated, we'll execute the spawn function. And whenever our marker is updated, we'll execute the wait for marker function. Finally, we'll need to make sure that this object no longer exists. It's not trying to run these two functions anymore. So to do that, we go on destroy, and then we repeat these, but we subtract the function instead of adding it. Now, if I go to enemy spawner, make our interval 1, And let's make this 4 for now for our power-ups. If I hit play, they should sound like they're triggering on or very, very close to. If they sound like they're triggering very close to, it's because I'm doing a pitch bend on them. So the kind of like transient attack time shifts a little bit because it's not right away in the sound. But they are actually triggering right on the beat, as like on the frame update that's as close to the beat as possible. And it looks like we have an error. Ah, forgot to set this to an int. Oh, one thing we want to do really quick is hit wait for string on our spawner. Now if I hit play, and as you can tell, it's now playing right on the beat. So the next thing that we want to set up is, if I play again, you'll notice that our shots are not at all in time with the beat. And what if they were? So that's the next question that we're going to answer. So for that, we're going to need to open up our player controller script. And in this, we're basically going to do the exact same thing we just did, although the logic is a little stranger. It's a little more convoluted. But really, it's not that different. The first thing that we're going to need to do is make our shot timer an integer as well. And because we're passing in that from our projectile stats, we'll need to go to the definition of our projectile stats and make our shot interval an integer. But from here, we'll scroll down to our fire event, and we're actually going to change the function of this event. Instead of it firing, we're going to basically have it check to see if we can fire. The reason I'm doing that is I don't want the very first shot to fire on the beat. I want it to fire whenever we click the mouse button down or fire the trigger, as long as we are able to fire. It just feels more responsive to me. It's kind of my concession that I'm making to gameplay instead of purely to music. So we'll start by renaming this. And we're going to change this so that we're doing the same kind of countdown method we were before. So if our shot timer hasn't expired yet, we don't want to do anything for now. But if it has, then we would like to create our projectiles. And additionally, we would prefer if our shot timer was being set to our shot interval specifically instead of updated based on a time difference. We don't need our timing information anymore. So this is all we're doing for enable fire. The other thing is it's enable fire that we want to check on update. In order to make sure that our shot timer is being managed properly, we will need a separate function for that. And this is the one that we'll be updating on the beat. We'll call this one update fire. And all that this will do is when a beat happens, we will decrement our shot timer, which means we'll decrement the amount of time remaining until our next shot is primed. And just in case, we'll never let it drop below 0. Now the final thing we have to do here is subscribe our shot timer to our beat event. And with that, all that we need to do is go into our projectiles and make sure that the properties on them are where we want them. In this case, our shot interval for our machine gun will make 1. We could create some extra scripts so that this would subdivide, essentially by checking the sample rate and then dividing that into chunks to create like a sub beat kind of method, but that would be a whole lot more code. Although that is something you can do, that we could make like subdivide into like triplets or half notes, quarter notes, eighth notes, etc. If you are doing triplets, you probably want to round your division up just so you don't end up kind of double firing. But we're not going to worry about any of that. Not for this tutorial. And we'll make our shotgun on 2, how about? So now if we hit play, our shots are on the beat, and if we have a shot ready, we can theoretically fire the first one off the beat and the rest will sync up. Just like that. Let's see if we can get the shotgun. Cool. So both of those are working, and now we have a pretty good example of spawning stuff on the beat, of creating some more complex logic for, I guess, a different kind of spawning on the beat, in this case our projectile firing. But there are tons of ways you can extrapolate this to, as I said. A tutorial that I've put together, it's a little bit out of date, but should work just fine from an ideation standpoint for how to actually do beat mapping. That tutorial kind of buffers all of the beats by 4 seconds or something like that, so you have 4 seconds of time ahead that you can read them in. But if you want to buffer in kind of a more reliable fashion, you could do something like save all of the beat events and their times to a scriptable object. I've done that before, and it works pretty well. It does mean you have a printing phase, like a baking down phase. And again, I'd love to hear if there are any better ideas on how to handle that kind of a problem, because the downside to this particular system is it does not work very well for buffering in stuff ahead of time and like reading when something's going to happen before it actually happens. It's much, much better for responding to beat events and marker data as it occurs. But cool, that pretty much does it for our beat detection system. I hope this helps a lot of you out. I know it's something that I've talked to a lot of people about and have seen a lot of people request better ways of doing this. It is a little bit complex and convoluted, but the code example gets you most of the way there. So I hope that helps you solve any of the problems with beat detection that you've been running into. With that, I hope you all are having an excellent week, and I'd love to hear from you if, again, you've got any questions or concerns on this tutorial or things you'd like covered in the future. Please feel free to reach out to me on social media. I'm always happy to talk about any questions you have about my tutorials or about FMOD in general, or just random Unity dev stuff. Thank you all for watching, and I hope you got something of value out of this. Until next time, have a good one.